Hello, hello. Welcome to SaugaTalks today. I'm Irene, the host, and I have two wonderful guests today. So we have Ed Peters, who is the founder and CEO of Data Discovery Sciences. Data Discovery Sciences, that's what it is. Welcome, Ed. Jim Sander is here.
Thank you.
Yeah, sure. And Ed's the only guy I know that admits he's worked with me in the past and we're still friends, I think.
This says a lot, Jim. Okay, so thank you so much for coming back to SaugaTalks. So Jim is an author and Forbes innovation contributor. He is a known analyst and he is an IT consultant in everything and anything. So to me,
I wish.
Jim is a guru I was following for many years. So absolutely, it's a pleasure. So let's talk about things that on our mind today. Because we're of course we're watching what's happening out there, and today is March 16th, so we're all aware of the news, and at the same time we're watching tech news. So this week I found wonderful article. I think it was very informative, from Bernard Marr on Forbes publication, and he is talking about coronavirus, but not only that, he is really exploring on how artificial intelligence, data science and technology is used to identify, to track, to fight, and even to produce supplies and help to process health claims. So I would like to ask Ed and Jim to comment, because you've seen this article before, and I think it's very, very cool application of technology that hopefully will help us to get over this time faster. So Ed, what do you think? Did you find these particular examples that Bernard is using? Is this something that resonating with you? Is this something that you're seeing in other places where you're looking?
Well, I think Bernard does a wonderful job here in not only discussing the use of artificial intelligence to predict, who might get the virus or how it might spread, but in all the other tasks where we might employ it, all along the chain from prediction to delivery of supplies, all the way to different parts of the infection chain where it might help. For instance, one thing we do at Data Discovery Sciences with our projects and clients is to make sure that we build a profile right in the beginning of all the tasks we're looking at and that are involved along a process stream, and then build a profile of that task and what technologies might be used to augment it or automate it along the way. And that what they call the whole front to back process. And I think that's what Bernard Marr does here wonderfully. He talks about, from the predictive analytics end all the way down to where we might use chatbots to be able to interact with people, to where the supply chain might be augmented with masks or intelligent masks, and how in each of those tasks that exist in that chain, where we might apply it and how it might be used. So it's not just single threaded into one area, but it has a broad expanse. And that's a wonderful thing for him to do.
Yeah, I had the same reaction that, he's looking laterally, not just trying to say, where can I drive AI deep here? And how do I drive AI the deepest? He went for the value chain, which includes the supply chain in this case. I think he did a terrific job. That was my reaction.
I agree.
Fantastic. So we'll be coming back, of course, as we're watching for new developments, and we do hope that that curve will flatten over time. So absolutely. So thank you for your comments here. Today, though, we wanted to talk about a little bit broader topic, and that is data, and that is how AI add value to data. So Ed suggested a few wonderful, important points to cover today. So Ed, this stage is yours. What do you think? Where the data is nowadays? What AI is helping us with, and where are some limitations still?
Well, the problem isn't that we don't have enough data. The problem is we have too much data, and it's everywhere. So how do you decide what's the most important data to use in your activities? Now, as we all know, models are fed with data, but if they're fed with improper or incorrect data, then the results aren't useful. And it's really an important thing to remember that data is the primary resource that's consumed by the models to produce the result that we want. So in understanding what data we should have to build what data sets that we need to drive the models we think best will drive an answer, it's data that we have to keep our focus on. Now, the most important question, of course, is exactly what is the question we're asking? In any type of situation for AI or model building, the first thing we need to know is what is the question we're asking? What's the outcome we're looking for? And then that business understanding needs to have some discussion of the actual cost function. So let's keep current with the coronavirus situation. What we're looking at here is how many staffed ICU beds do we have available at any point in time to be able to treat an acute coronavirus patient. That's really what we're talking about. Whether somebody gets sick or goes to the hospital, right? All those things lead up to that problem, which is how do we stop somebody or get somebody before they have to get to the point where we have the most limited resource, which is that staffed bed in an ICU with a respirator.
So Ed, do you think that happened because we didn't anticipate any of this and the system wasn't built for these kinds of peaks? You think that's why we're optimizing? We see, flatten the curve, flatten the curve, flatten the curve. You see, real-time simulations that say, if you, get separation, here's how it works with that constraint of the ICU bed. What happens if you don't do anything? And what happens if you have forced quarantines? And what happens when you do extensive, distancing, all voluntary? Is what you're saying that, the outcome driven, which is beds, is because we kind of backed ourselves into this corner, or it's just that's what we have to deal with?
Well, I think we're built for normal capacity. For instance, when we see the flu, what we learned is that most of the cases that result in mortality, which is what we're trying to prevent here, occur in the over 70-year-old part of the population. So if we look at cohorts and you look at what happens between over 70, over 65, and over 55, then you wind up with over 90% of the cases of mortality in that range. So we've built ourselves to understand how to work with a normal flu virus, a normal flu event or flu virus event that happens on a yearly basis, which drives a lot of mortality. But we can handle that because it's relatively flat. Now, when we go to a case where there's a sudden outbreak, now we have a surge capacity problem. If everybody shows up at the peak at the same time with something that needs a respiratory treatment that requires an ICU bed, now we don't have the capacity. And it would be outrageously inefficient to build for that capacity because it would go wasted. So you're caught on this balance here between what do we normally expect to happen and then how do we provide a surge capacity. I happen to know that there have been numerous simulations and events where massive catastrophes were looked at and what were the biggest effects. And it's an amazing thing when you look at what comes out of that. At the same time, building for surge capacity is one of the questions that's not been addressed as a society. For instance, who would pay for it? Where would it be located? Who would administer it? There's a lot of issues here that we as a society would not address until we're faced with the problem.
Yeah, I was kind of impressed with the way China dealt with the surge capacity. They mustered all of their manufacturing capabilities and building capabilities and built these temporary hospitals very, very quickly. Obviously, our government hasn't thought of that one or can't get agreement to do that.
Well, I think they actually have. I think that's where we're seeing Walmarts and the Walgreens and a number of other providers in the healthcare space now, for instance, open their parking lots to be able to accept FEMA to be able to come in and bring their trailers that actually implement an immediate surge capacity around the nation.
So it's more than just the testing at the parking lot. They could park ICU units.
Oh, exactly. I think that's what you're seeing right now, is that those parking lots and all that space will be used to be able to build surge capacity treatment centers.
So it's better to do, the FEMA approach than it is to build something that's a facility like the Chinese did. So our approach
actually, Jim,
might be better.
at hospital, we all saw this amazing video, right? How they're building it in front of our eyes. But thing is, there was also reports that the hospital was empty, few weeks after, because frankly, right, it's built full capacity at hot moment, but frankly, this passed. So yeah, it's definitely balanced, and all the analytics and predictive modeling should help us here to make smart decisions with investments and, resources, and of course,
Yeah.
right?
So
Yeah.
having a mobile FEMA approach is better in the overall view.
Yeah, but we're learning, right? As humankind, we're learning, and I'm sure we'll come up with solutions that help us to prepare for what's come next. So going back to data, Ed, though, right? So we wanted to talk about what data sets that have been fed to the model, because coronavirus or no coronavirus, we will still be dealing with a lot of data not ready to be taken by AI. To talk in simple English. So what's your point? What some of the optimization approaches that you're seeing happening?
Well, once we understand what the outcome we're looking for and what question we're answering, and there's a multitude of questions to answer, that starts to drive the types of data sets we need. And then we work our way back in the chain to look at the actual data that's available. And once we understand that, now we start what amounts to be a refinement process. It's almost like pulling out the resource and now going through refining things as if it was a petroleum product or anything else you mine. It is now we have to actually make sure, where did the data come from? What's the veracity of the data? How do we know? When was it collected? And are we making sure that when we bring this data together, simple things like we're not comparing apples to oranges. We have the dates all aligned where they're similar. We make sure that all of the values are the same. It's an amazing thing. You would think that would be true always, but it's not. Some might be in milliliters, some might be in other measures. All those have to be mathematically normalized before we can actually normalize the data itself. And then we have to look at making sure that once we have those data sets, that they're actually giving us some reasonable expectation of the answer we want. And now, usually it's not true the first time through, almost never true. So now you're back looking at, how do we have to enhance this data? Are there different periods we need? Are there aggregations of the data we need to make to be able to enhance our ability to get a useful answer? And in the data science world, a lot of that is all about understanding, basically true positives, false positives, true negatives, false negatives. And what's our accuracy then of being able to make the proper prediction based upon that data we have? And oftentimes we find out that maybe we're only 48% accurate right now, and we need to keep coming back and looking at the data and possibly bringing in different data and different training sets to make sure that we're actually now reaching some threshold level of understanding we want. It's not a quick, and it's not an easy process. So we just don't pull data, put it in, and here's what it looks like. That's great for simple statistics, but not when it comes to actually making a predictive model at a threshold level of accuracy that we need to be useful in a case like this.
Yeah, and I think there are a good number of people out there that say, keep storing data, keep storing data, keep storing data. And they have all this data and they want to find a reason from an accounting standpoint to use it. What you're saying is that's the wrong way to do things. The right way is to start off with the goals and focus in on the data and then get it better, refine it, correct it, normalize it, and make it work for you. Do you think, we'll get better at data because of this particular situation, or better at models?
Well, I think we have the possibility to become better at both. I mean, the more we exercise our abilities here, and the more we do problems, the more we'll learn, what type of data we need, what classes of data, and then what they call cohorts. Basically, that's simply demographics, particularly in how you're classified, and how, into what maybe your zip code and near your hospital. How we go through this tells us how efficiently we're actually coming to an answer. And the more we do that, the more we'll learn for the next time when we made pre-stage data, because we know from now they call the metadata standpoint, what types of data we need and how we need those data pre-staged so that we can rapidly pull them into the process and then drive them into a model that will give us some level of understanding of the problem.
Yeah, so what I heard there is there may be a possibility to feed some of this back into the community to say, hey, look, we're over surge protected in this particular zip code and we're underserved in another one.
Oh, exactly. If this is a capacity problem, which is what we're being told, and the government is doing the right thing here by actually testing, people over 70 with a priority, because people under 20 seem not to get this very often. And under 9, there's no cases reported that I've seen. Now they're putting their resources on the highest mortality-driven types of cohorts and then backing their way through. And now we'll understand once we've been through this, and unfortunately, we won't have the data until we've been through it. And not just us, but the Italians, the South Koreans, worldwide, will have a great database of experience with this that'll help us fully understand, at least as much as we can, what happened and then how to use that to build models to help us get through the next outbreak a lot better and a lot faster.
Ed, I like this angle we're taking, accounting versus or with data scientists, okay? So let me ask you this, what scientific principles are the most crucial when we're looking at the results, when we're looking at the reports and findings based on data sciences, the approach here? Mm-hmm.
Number one, how was the question formulated and what was the cost function that was being optimized? For instance, hospital beds, what was it this was answering specifically? Just because we have a number does, what did that number represent? And what was that outcome we were looking for? That's number one to remember. Number two, we need to really understand when we gone through this, that what was the accuracy level we had? There's a lot of people that throw numbers out there. And when you look at, tell me the accuracy rate of that number, you find that it's less than 50%, in which case it's less than tossing a coin. That's not good. And I bring an example here, and we've all read a lot of it, is in the case of facial recognition software used in law enforcement. There are some technologies and approaches that bring in that facial recognition software, bring in that actual match at over 90%, provided that the light was correct and all these factors. When you drop below that, the threshold becomes 60 or less in a lot of cases. Well, now, that number isn't always published. And when you start to push for, tell me the accuracy of the algorithm, now you start to get to a real look at, oh, that really wasn't that good, was it? Now, that's what we need to understand. And we start verging on the discussion of algorithmic transparency. Not only is the data an issue, but the transparency on the algorithm that produced the result based on the data starts to show us how good it was or not. And we need to be clear with everybody just how valid and how accurate the predictions are.
Yeah, so it's more than explainable. It's, how accurate is it and under what conditions is it accurate? Wow.
I need to bring up the ethics here, okay? Because every time I hear facial recognition and efficiency in that area, I start thinking about AI, good or evil or somewhere in between, okay? And a lot of other things. So we talked a lot about ruling, about humans still need to put some limitations. What's your take on this, Ed?
Well, I think that's what Dr. Fauci was talking about when he made the comment that, oh, it's a model, you can make it say what you want. That without this level of transparency and full understanding, we don't really know what it's saying. The scientific approach says that we really need to be clear about this and publish all of these factors along with it, so we have a real understanding. And ethically, as scientists, we need to be, one, extremely transparent. I mean, that's the whole point of peer review. Right? Other people that make sure they read your results and make sure that they agree you follow that approach, and then make sure that it's actually correct. Otherwise, what we have is just a lot of people driving agendas into the market for no reason. I mean, why do we have a toilet paper apocalypse going on? I mean, for a respiratory disease, not a GI tract disease.
I'll tell you what I think the reason is. The news casters were saying do it. So people like lemmings will do it. I mean, they said, go get water, go get toilet paper, do it now. Well, that's what you're going to get.
We're also human, right? And how will take account of our very natural behavior in case where sometimes it's okay to take a breath, and it's okay to kind of look around and see that, hey, you know, we're okay. We're okay in my area. So point is, yes, and going back to your point, so AI is a tool, and we humans responsible what we do with the tool here, don't we?
Yes, like any other tool, we're the ones that are responsible for its use. And its use can be, as you mentioned, for good or for evil, right? But the technology itself is neither. We have to make sure that we're responsible in using it. And as data scientists or data engineers, we need to make sure that we're actually promoting the correct understanding of the information, and especially its limitations. You know, Professor George Box was famous for saying, all models are wrong, but some are useful. And being that they don't represent reality correctly 100%, but something can make them useful. And we need to be the ones that ensure that what we're providing out there is useful, and be transparent about its limitations, a lot of which come from what type of data is used.
Ed, after the dust settles on this, and we think it will, when we get through however this curve is, peak or flat, there's going to be a lot of data. There's going to be a lot of models that have come out of this. And, you know, the scientist part of our society wants to share that. They want to share the transparency. What happens when we get into the geopolitical cybersecurity world where people don't want to cooperate? Or would you predict that this kind of thing brings all of humankind together, and we're going to want to avoid this? Where do you see this landing?
Well, I think the opportunity is there for the latter, in that given the internet today and the ability to publish things and the ability to publish models, an interested community can actually work together to share these cross borders. I don't see necessarily the government's interfering unless there is something that was developed on a highly classified basis, which I'm sure there will be. But that's a separate case. But normally, those of us who build these types of models can use them and exchange what we found with other people in the right forums as a public service. And I think one thing Bernard Marr was pointing out, that is actually happening right now in a number of cases.
Yep. Very well, very well. So thank you. Yeah, thank you, Ed. Thank you, Jim. So to kind of wrap up, because we will be coming back more and more for yes, watching the latest news and understanding exactly, is it what part of the technology that we see playing in the whole developing a solution, right? Is it growing or it's diminishing? So maybe we can handle the old way, a lot of challenges that we're facing. So point is, can we bring a lot, kind of 3 takeaways, Ed, to our audiences, saying when you're working with data, when you're looking at data, okay, what is it that you need to be worried about when you preparing data to be fed into AI, and what is the outcomes as reviewing results, is understanding what those data, what mechanisms produced for us?
Well, number one, have a complete understanding as you can of the question being asked and the reason why, right? Which we tend to call the cost function. You know, what happens what is the cost of a wrong prediction? For instance, if I predict that you do not have coronavirus and you do, right? Well, obviously that means you can spread it to more people and it becomes a bigger problem. So that's number one. Understand that. And then think about what data you might have that relates to that problem and how that problem can be solved by understanding the basic items of the data. And then number three, what's both the quality, and I call that the truthfulness or veracity of that data. You know, how reliable is it? How much do you really think it's going to be used? And then understand that it's not an easy process, that it is going to take time and a lot of diligence to make sure that you can refine it to build the best data set and derivative data sets possible to help drive that answer to the highest level of quality.
Perfect. Jim, do you have your points for kind of, to leave our audience with?
Well, yeah, what I'd like to see, and I don't think there is one, is there a standard for talking about the accuracy of a particular model and the accuracy of data. I agree with Ed that, just storing data to store data without a goal is kind of senseless. And that seems to be what the whole industry is doing. We're talking about data lakes, we're talking about big data, and we've talked about fast data, but those things don't mean anything without knowing some of the questions. Now, obviously, with emergent problems like we have with the coronavirus, we don't know all the things to optimize on. And it might differ by country, it might differ by geography, might differ by people class, because certainly the death rates for 80 and plus are 15%, and those that are under 9, it's 0. So knowing how this model is being used is correct. And I think there's a bigger lesson for all companies to learn. Identify your goals, your purposes, and what you want to do before you start collecting gobs of data.
Perfect. Yeah, thank you. So thank you, Ed. Thank you, Jim, very much. We'll come back to very interesting topics. So you're always welcome to come back to SaugaTalks and to our audience out there. We are posting a few times a week, sometimes shorter snippets, sometimes the whole episodes of our discussions, and we are dedicated to continue going. So please check us out, view, comment, and subscribe. We need this channel to be growing. And thank you so much for the guests again, Ed and Jim. Thank you. Have a nice day. Thanks.
Bye now.
Bye-bye.